What if I told you the universe doesn't play by the rules you've always believed? That the tiniest particles in existence can be into places at once, or even connected across galaxies in an instant. Welcome to the weird, wonderful, and utterly baffling world of quantum physics. In this episode of Hot Blimp, we're peeling back the fabric of reality itself. You're about to discover the secrets behind two of the most mind-twisting quantum phenomena ever imagined: superposition and entanglement. And trust me, by the end of this video, the way you see the universe might never be the same. To understand how strange things can get, we need to start with the basics. Quantum physics, also known as quantum mechanics, is the science of the very, very small. We're talking atoms, electrons, photons, particles so tiny they follow a different set of rules than the ones that govern your everyday world. In the world of classical physics, everything is neat and predictable. Drop an apple, it falls. Push a cart, it moves. But zoom into the atomic level, and the laws of nature start to act strange. In the quantum realm, particles behave like both particles and waves. They teleport, they appear out of nowhere, and sometimes they seem to know what you're about to do. It's not science fiction, it's quantum reality. Here's where things really start to bend your brain. Let's talk about superposition. Imagine flipping a coin. While it's spinning in the air, it has the potential to be either heads or tails. But in quantum physics, a particle isn't just waiting to become one or the other, it's actually both at the same time. That's superposition. A quantum particle can exist in multiple states simultaneously until someone observes it. Think about that. An electron can be in multiple locations. A photon can go through two doors at once. It's not until we look that the particle decided where it really is. One famous example is Schrödinger's cat, a cat in a sealed box that is both alive and dead. Until someone checks. It sounds ridiculous, but it's a powerful metaphor for how bizarre and real superposition is. And the best part isn't just theoretical. Real experiments, like the double-slit experiment, have proven that particles can interfere with themselves, as if they traveled all possible paths simultaneously. Let that sink in. Now, if you're still with me, and you should be, because it gets even crazier, let's take a peek at the math that describes this surreal behavior. Quantum physicists use something called a wave function, symbolized by the Greek letter psi, to represent the probabilities of where a particle might be. Not where it is, but where it could be. This wave function spreads out like a cloud, and every point in that cloud represents a potential reality. When we measure the particle, boom, that cloud collapses, and we see just one outcome. Before that, it was in a soup of all possibilities. This is why quantum mechanics doesn't deal in certainties, but in probabilities. And that changes how we think about reality itself. Ready for your mind to really break? Let's talk about quantum entanglement, something Einstein himself called spooky action at a distance. Here's the deal: when two particles become entangled, they're linked in such a way that whatever happens to one instantly affects the other, even if they're light years apart. Imagine two dice rolled on opposite ends of the universe. If one shows a 6, the other will too, no matter the distance, no matter the delay. And this connection doesn't rely on signals or time. It's instant. That means reality isn't as separate or localized as we once thought. Everything might be far more connected than we ever realized. Entanglement isn't just weird, it's useful. It's being used right now to develop unhackable communication systems and quantum computers capable of solving problems our current tech could never dream of handling. Quantum physics might sound like science fiction, but it's already shaping our future. Scientists and engineers are developing quantum computers that use superposition to perform millions of calculations at once. They're building quantum networks that use entanglement for ultra-secure communication. And quantum sensors are being designed to detect even the smallest changes in gravity, motion, and magnetic fields. We're not just studying quantum weirdness, we're harnessing it. So the next time you wonder about your place in the universe, remember this: reality, at its core, is a swirling ocean of probabilities, connections, and possibilities. Quantum physics doesn't just describe the invisible, it redefines the impossible. If your mind's been blown even a little, make sure to subscribe, hit that like button, and share this video with someone who needs a dose of cosmic confusion. And stay tuned, because in the next episode, we're going even deeper. Time travel, wormholes, and whether parallel universes might be more than just science fiction. This is Hot Blimp, and you're now thinking quantum.